All right, so it's called Properties of Logarithmic. In this section, we're going to learn how to expand and condense log statements, which are also ln statements. So it starts with the change of base formula, okay? And this is what is used when you are, let's say you're trying to find the log and the base is not 10 or the base is not e, right? So our calculators have a button that says log and our calculators have a button that say ln. And log is log base 10, and ln is log base e. But what happens if that is not the case? What happens if you had something like log base 3 of 23? Some calculators can do this. Your graphing calculators can. It's like under the math menu. There's a thing called log base that you can actually type that in. But any other calculator, you would have to rewrite this as a ratio of common logs, which is what this is. Like common log is log. So if it said common log, change the color, common log, it means log base 10, or as a ratio of natural logs, which is your ln's, natural logs. And the way we rewrite it is you do log of the physically larger number, not larger in value, but the larger one goes in the top, and then the little guy next to it is called a base, and the base goes in the bottom. And you can do this with any log. Like I could have done log base 5 of 23 over log base 5 of 3. You can literally log and break apart each of those. But that would be pointless because if your calculators don't have a log base 3, they're not going to have a log base 5. So what your calculators can do is log 23 over log 3 or ln 23 ln 3. And those will give you the same answers. So if you'll pull out your calculators and test it out, you would see something like this that says rewrite the log as a ratio of A, common logs, and B, natural logs, and then use the calculator to evaluate the log and round to 3 decimal places. So this kind of question in parts could be either on the non-calc portion of your test or the calc portion of your test. On the non-calc portion of your test, it could ask you to just do A and B, where you rewrite this as a ratio of the natural log or the common log. Then obviously with your calculator, it could ask you for the second part. So if I were to rewrite this as common logs, that's log base 10 or just log of 5 over log base 10, which is just log, over log of 8. If I rewrite it as natural logs, it's ln of 5 over ln of 8. Okay, then put them over, you should get 0.7739, good, which rounds to 0.4, or 0.774, okay. Then again, I'm gonna show you, so if you have a graphing utility and you go to your math menu, you go to math, there's a math button. And you could either scroll all the way down or you could actually arrow up and it will bring you back to the bottom of your list. But under A, there's a thing that says log base. If you click on that, it allows you to change it will actually bring up log and then the little base here and then the little guy here. And you can type in your base 8 and 5 and you get the 0.774. So again, great way to check it, but also like not all the calculators have this, which is why you can always fall back on this. And I will ask you to do this without a calculator, so make sure you know how to do both things, okay? All right, now we're going to talk about this one, the product property, the quotient property, and the power property. And we're going to do these in both directions. We're going to use it to expand and we're going to use it to condense it. So if I have one log at the beginning, I literally have one log, and it's finding the log of a product, two things being multiplied together, then I can expand it into multiple logs by taking that product and turning it into an addition statement. So if it said log base A of u times v, this becomes log base A of u plus log base A of v. And the reason this happens is because logs are just another way of writing an exponential expression, right? We know that. We can go from log to exponential back and forth. So if I focus on exponential functions, if I had x squared times x to the third, what do I typically do with my exponents? I add them. So when we multiply, we add. Then if I go to division, so I have a fraction, okay, then it becomes subtraction. When I break this apart, log base A of u minus log base A of v. And this is because if I had x to the fifth in the top and x to the second in the bottom, what do I do with these exponents? Subtract them, okay? And then the last is the power property, which says if I find the log of something with an exponent, that exponent can get bumped to the front and changed to multiplication. And again, think about why this happens. If I had x to the second raised to the third, when I raise a power to a power, what do I do with them? I multiply. So we turn it into a multiplication statement, okay? So all of these properties come from properties of exponential functions because logs are just another way of writing an exponential function. Now we will use this in both directions. We will take something that is a product, we will break it apart as an addition statement, and we will take something that's an addition statement and we will condense it into a product. So you're going to both expand and condense. Example 3. It says use the product rule to expand. So first of all, at some point it might just say simplify, or it might say expand or condense. You would have to know which one to do. In this case, I only have one log in each of these questions, so I know I'm expanding. So log base 3 of 9 times 5, that's multiplication. What's going to happen when I expand it? Addition. So this becomes log base 3 of 9 plus log base 3 of 5. With me so far? Now you have to say, can I simplify any of those?
So double checking, when it's multiplying, you add it. When you expand it, when it's division, you subtract it.
Correct. So is there any of that I can simplify? Can I raise 3 to a power to get 9? Can I raise 3 to a power to get 5? Which one? The 3 log base 3 of 9 becomes what? 3 to what power is 9? 2. So if you can simplify, you need to. Go to B. Product again. So when I break it apart, it becomes log of 1,000 plus log of x. Can I simplify either part of that? Yeah, this is a 10, right? So 10 to what power gives me 1,000? 3, count your zeros. This would be 3 plus log x. And you can put log base 10, but you don't need to because log is log base 10. Now go to C. Log base 5 of 25 over x. So this becomes log base 5 of 25. What do we do when we divide? Subtract. Good. Log base 5 of x. And log base 5 of 25 is 2. Still good? Yes? Okay, now we got ln. And ln is the same thing as log base e, so we treat it just the same way. Now I've got ln e to the third minus ln of 8. We go down that step. Now I kind of have two choices. What's one of them? Good. I could bump this to the front because an exponent goes to the front, and this would be 3 ln e minus ln 8. And then ln of e becomes what? 1. So this would be 3 times 1 minus ln 8, or 3 minus ln 8. There was another option up here. Do you see it? What? We did that one. What's the other option?
Oh, sorry. I thought you did the other one. Cancel out that one.
Good. ln e cancels and gives me my exponent. So this is 3 minus ln 8. You can do either way. So all these rules will carry over, okay? All the simplification rules from before, and now we add in the expanding and condensing will all be the same. Good so far? Okay. Try them. All right, what are you going to do in A? Good. So bump the 2 to the front, and then I get log base 5 of 7, and you can't simplify 5 and 7, so we leave it. Okay, how about B? More than one way to do it. What's one? Bump the 4 to the front at the beginning. So one option is bump the 4 to the front at the beginning, and then I get ln of 8x. Then when I expand, right, it becomes?
ln 8 plus ln x.
Good. So what you have to be really careful of is that 4 is going to go to both. So when the 4 got bumped to the front, the other option would have been to give each of these the 4, then expand it, and then bump it, which is one option. If you bump it at the beginning, you have to remember that that applies to both. So it'd be 4 ln 8 plus 4 ln of x. So be really careful with those exponents when you have more than one term, okay? Now C, what's the exponent if it's being square rooted? 1/2. So this is the same thing as saying log x to the 1/2, and then that 1/2 bumps forward, and I get 1/2 log x. Then I go to D, and I get log base 5 of 25 minus log base 5 of y. And log base 5 of 25 is 2. So this is 2 minus log base 5y. Okay, then it gets super tricky, and this is the most common mistake made every single year. So if you are not listening to me, wake up, open the ears, and listen. If there are more than one term in your numerator, then when you separate it, they both get a plus because it is multiplication. If there is more than one term in your denominator, they all get a minus because it would be minus a product, and then when I spread it out, all of those get the minus. So if it's in the top, it gets a plus. If it's in the bottom, it gets a minus, which means this is ln, starts as ln e to the second minus ln x to the second minus ln y to the third minus ln z. Every year somebody makes a mistake on that one, and every year it's the same mistake. They put a plus at the end. Don't do that. If it's in the top, it gets a plus. If it's in the bottom, it gets a minus. Okay? Yep.
Would you move the exponent?
Then I got a bump. Yep. Everything. Well, for ln of e to the second, I can actually simplify. Just make it 2. But then the other 2, this becomes minus 2 ln x minus 3 ln y minus ln z. Jules.
Could you do 2 minus 2 ln, like parentheses? The 2 on the minus.
As long as you then make ln e 1. Is that what you mean? Mm-hmm. Yeah. Good? Okay, now we're going the other way around. So now we start with multiple logs and we put it into 1. This will also be done next week when we do expanding. When we do solving equations. If you have multiple logs, you're condensing. So now we've reversed it. If it starts as a plus, then it becomes a multiplication. If it starts as a minus, it becomes division. And if it starts as a product on the front, it becomes the exponent. Now, if there's more than one mixed together, if it said log base b of m minus log base b of n plus log base b of o, the sign determines where it goes in my fraction. It doesn't matter the order. The sign being positive here says that's going in the numerator. The sign being positive here says that's going in the numerator. The sign being negative on this one says that's going in the bottom. So I would get log base b of m times o over n. Because order on addition subtraction doesn't matter, right? I can move that around in any order I move. So I can't assume that this is a negative and then that negative would get carried over unless it was in parentheses. If it's in parentheses, then obviously it's going to affect both. But if not, if it's a positive, it's in the top. If it's a negative, it's in the bottom. Even if the leading was negative, it would go to the bottom. All right, let's condense them. So A says, and we're not going to worry about simplifying first, we're just going to condense. So technically log base 2 of 4 could become 2, but that would be if we were expanding and simplifying. Now we're condensing. So this is addition, which means what? Multiplication. So this would be log base 2 of 4 times the square root of 8. Then I get minus for B, log of 6x minus log of 6, and that becomes log 6x over 6. Now that can get simplified, right? Because these literally cross out. So you get log of x. If it just says condense without simplify, I would take either answer. If it says simplify, then you would need to do the second one. Now C, the first thing you want to do is bump your exponents. So 2 goes to the 9. So this becomes log base 3 of 9 squared minus log base 3 of 27. And then because it's minus, it becomes what? Division. Log base 3, 9 squared over 27. And again, if it just said condense, I would take that answer. If it said condense and simplify, I'd have to keep going. This would be log base 3 of 81 over 27, which is log base 3 of 3, which is 1. So if it just said condense, you're done here. If it said simplify, you'd have to keep going. Okay, last one. ln of x minus 2 plus 5 ln x. So the 5's going to the exponent. ln of x minus 2 plus ln of x to the 5th. Plus means multiplication. So ln of, and it could be x minus 2 times x to the 5th, or it could be ln of x to the 5th times x minus 2. Either of these are fine. Order doesn't matter. Good? We'll go back to that last example that I skipped. So go to I'm going to come back to this. So example 2 is a way for it to test you with a calculator without the calculator actually being able to do it for you. This one says approximate the log using the properties of logs, given log base b of 2 is 0.3562 and log base b of 3 is 0.5646. So what it doesn't want you to do is, like, there won't be a value here, okay? What it doesn't want you to do is just take your calculator, do your change of base, and get your answer. It wants you to use log base b of 2 and log base b of 3 as somehow part of the expanding or condensing of these logs. So if you looked at, like, log base b of 6, can you rewrite 6 in terms of 2 and 3? Yeah. It would be what? 2 times 3. So I would rewrite this as log base b of 2 times 3. Now use your expansion, right? Which if it's multiplication, it becomes addition. Log base b of 2 plus log base b of 3. And then substitution says log base b of 2 is 0.3562. And log base b of 3 is 0.5646. And then we just add. So literally line them up and add them. 8, 10, 0.908. Now use your expansion rules on B. What's one way to do it? Because there's more than one way. You can bump the negative 3 to the front. Negative 3 log base B. Is that what you meant? Or did you mean distribute it? Okay. 3B. Then expand becomes addition, but they're going to both get that. Log base B of B. It's a terrible B, but that's a B. Okay. Now I could distribute, or what do you see there that could be simplified already?
The log base b.
Log base B of B is what?
1.
Good. And then log base B of 3 is 0.5646 plus 1. And I get negative 3 times 1, 0.5646. So 1.5646 times 3. And there's 4 digits behind, and it's negative, so negative 4.6938. So this is the stuff like standardized test love, because you can have a calculator there, but it really doesn't help you figure out the log. It helps you do the math on it, but you have to use your expansion powers and that kind of stuff to break it apart, or expansion rules.